Okay, so today we're going to be talking about special right triangles. I'll probably break it up into two different videos, one for 45, 45, 90, and one for 30, 60, 90. Depending what part you need to see, then great, because they're both really special and they're really helpful. The Pythagorean theorem works for all right triangles as long as you know two sides. But if you have Pythagorean triples. Those are special ways to know the missing sides. And then also, if you have, the angles, then these are really amazing ways to say, I even know just one side and I can find the other two sides. And you will use these special right triangles many, many times as you take classes because they're really foundational to trigonometry. And so we will revisit these at the end of the year, and then you'll absolutely see them in Honors Algebra 2. You'll see them in pre-calculus, you'll see them in calculus, and most of the classes you take after this, this is a really important part because they are kind of beautiful with their symmetry. And the side lengths actually are quite lovely. And we just really do a lot of math with these foundational triangles. So let's go ahead and start about with 45, 45, 90s. And so just a reminder, special right triangles would be an example would be the 45, 45, 90 and the 30, 60, 90. Those are special. Okay, why are they special? Their side lengths are actually pretty helpful. There's a beautiful symmetry going on there. You just really truly use them a lot. Okay, a Pythagorean triple would be is if all three sides are whole numbers. Okay, integers is true, but whole numbers is probably a better choice. So each side is a whole number. And then isosceles right triangles is what we're going to be talking about today. If you got a right triangle and two of the sides, the legs are congruent, then you have an isosceles right triangle. So that's going to be what we're talking about today. And so if you start with a square and you draw the diagonal, okay, you're going to be forming an isosceles right triangle. Okay, and in this triangle, you may notice that the acute angles are both 45 degrees. Okay. And so that's a triangle that we're going to be talking about. An isosceles right triangle where the two acute angles are 45 degrees and the legs are congruent. That's what we're going to work on today because the three sides of an isosceles right triangle have a beautiful relationship together. And so we're going to investigate this. So let's talk about, let me get my notes fired up. Okay. And so I've got kind of my talking points ready to go. Okay, so let's just kind of explore them a little bit. Okay, pretend that these two sides are three. Okay, we don't know they are. I'm just saying pretend they are. What would the hypotenuse be? Well, the hypotenuse would be 3 squared plus 3 squared equals x squared. And that'd be 9 and 9 equals x squared. That means 18 equals x squared. That means the hypotenuse is square root of 9 square root of 2 or 3 root 2. So the truth is that if the legs are both 3, because it's isosceles, the hypotenuse can be found pretty easily by doing the Pythagorean theorem. But the truth is that there's actually a really special relationship because all 45, 45, 90 triangles are similar to each other. That means they're proportional. That if you actually had a square and the sides actually are 5, guess what the hypotenuse would be? Okay, of course, these would both be 45 degrees. The hypotenuse would actually be 5 root 2. Okay. And if you put in your calculator 5 root 2, root 2 is like 1 point something. So 5 times 1 point something does give you a number bigger than 5. So the hypotenuse has to be longer than the legs. But the weird thing is that anytime you have an isosceles right triangle, the legs will be congruent and the hypotenuse will be bigger by a factor or by timesing by root 2. So if you know the legs to get to the hypotenuse, you can do the Pythagorean theorem, but there's no point. You can just times the legs by root 2 to get to the hypotenuse. And so that's going to be what we're working on. And so if we show this kind of abstractly to kind of say what would be the hypotenuse, for all of them, like if the legs are X, what would the hypotenuse be? Well, the hypotenuse would be actually x root 2. Whatever the legs are times root 2. And so we can show that doing the Pythagorean theorem if you feel like it, okay? That would be 2x squared equals c squared. And so if you want to just get the length of hypotenuse or c, the square root of x squared is x, the square root of 2 we don't know, so hypotenuse would be equal to x root 2. So that's going to be the special relationship, okay? And the rule that we're going to talk about would be that, here we're going to write rule, okay? In isosceles, right triangle, legs are congruent, the hypotenuse is longer by a factor of root 2, okay? And then legs divide by root 2. Okay, so if you know the legs of a 45, 45, 90, or of an isosceles right triangle, you can times them by root 2 to get to the hypotenuse. On the flip side, if you know the hypotenuse, you can divide it by root 2 to make it smaller to get to the length of the legs. So that's going to be kind of the gatekeepers. Say, if you know the legs, you times by root 2 to get to the hypotenuse to make it bigger. You divide by root 2 to get to the legs. And so now basically the rest of these notes are going to be us saying, can we practice either timesing or dividing by root 2? Okay, and so here we go. I'm going to get a little bit different color. So it says if FE, so FE is 6, 6 units, and this is 6 units, what would be the hypotenuse? Well, that would be 6 root 2, and that would be units. Okay. If FE is 3 root 6, well, and we could put units on it. This would be 3 root 6, and that would be in units. To get to the hypotenuse, we want to make it bigger, okay? So we are going to multiply by root 2. So 3 root 6 times root 2 gives us 3 root 12. Oh, we should break it up, okay? So to break it up, we're going to do root 4 and 3, which is 2. Remember, to multiply those together, you get 6 root 3. Multiply these two numbers together. So it'd be 6 root 3. And then we can label that in units. Okay, so if you put in your calculator 3 root 6 and 6 root 3, 6 root 3 is bigger than 3 root 6. If you look at the decimals on there. Okay, EG is 5 root 2. Okay, so we want to get to the legs. We have to divide by root 2. How do you divide? Okay, you basically, if you want to divide by something, you could write the division sign, but a smarter choice is actually to put it over root 2. Okay, so this means to divide. Okay, and so if you're like, I've got 10, I want to divide by 2, well, you put it over 2, and that gives you 5. In this case, it's a little uglier. We're going to take the original leg, the hypotenuse, and to put it over root 2. In this case, root 2's cancel out, and your answer for the legs is going to be 5 units. Okay. If EG is 12, okay, we need to find the other two sides. So again, to get to the legs, we want to divide by root 2. So how do you divide by something? You put it over it. And so that is true, but we need to rationalize it. So to rationalize it, we're going to times top and bottom by root 2. We get 12 root 2 over root 4, which is 2. These coefficients will reduce. Okay, so you get 6 root 2. We can label these units, all these guys. There you go. EG is 9. We want to find the leg. So again, how do we want to get smaller? So divide by root 2. Rationalize it. 9 root 2 over 2. Those coefficients, the 9 and the 2 don't reduce. So it's 9 root 2 over 2, excuse me. And these would all be units. Okay, so here's the summary. if you have a 45, 45, 90 isosceles triangle, to multiply by root 2 to get from the leg to the hypotenuse. Because you want to make it bigger. Simplify as you need to. If you want to go from hypotenuse to the leg, we're going to divide by root 2 to make it smaller and rationalize as you need to. Okay, let's go. So we would need to find these missing sides. And so we know that the legs will be both the same. And then to get to the hypotenuse, we are going to times it by root 2. So 6 root 5. And you're going to times that by root 2. And you get 6 root 10. And that's units. Here we know the hypotenuse. So we're going to divide it by root 3 or root 2. So multiply by root 2. This one we're going to divide by root 2. And we have to rationalize it. So we're going to times top and bottom by root 2. You're going to get 4 root 6 over 2. Square root of 2 times square root of 2 is square root of 4. These coefficients will reduce. So your answer is going to be 2 root 6. So it's going to be here, 2 root 6 and 2 root 6. And these are in units. Okay, the next one, both legs are 4 root 3. They give you one leg, and that's in units. To get to the hypotenuse, we are going to multiply because we want to make it bigger. So 4 root 3 times root 2 is 4 root 6. Okay, here we know the hypotenuse. We're going to divide by root 2. So 17 divided by root 2. We will rationalize it because we can't leave a square root in the bottom. You get 17 root 2 over 2. And these are in units. All right, we just have a couple left. If you know the hypotenuse, we are going to divide by root 2. So 100 divided by root 2, rationalize it. Reduce the coefficients, it's 50 root 2, and that is going to be units. These are both 3 root 2 because they're legs. To get to the hypotenuse, you're going to multiply by root 2 to make it bigger. So you get 3 root 4. Square root of 4 is 2, so it's going to be 6 units. And here we know the hypotenuse. We're going to divide by root 2. So 8 root 5 divided by root 2. We can't leave it like that. We've got to rationalize it. You get 8 root 10 over 2 or 4 root 10. And that's units. This is 4 root 10 and that's units. All right, there we go. All right, last one. Given the diagonal is 20 centimeters of a square, tell me the perimeter and area. Well, if it's a square and it's a diagonal, these are both 45. So we're going to divide by root 2 to make it smaller, and we're going to rationalize it. You get 20 root 2 over 2, or 10 root 2. That means that all 4 sides of this square are 10 root 2. So the perimeter would be 10 root 2 plus 10 root 2 plus 10 root 2, 4 of them, okay, or you can times it by 4, and you get 40 root 2, and that is going to be in centimeters. To do the area, you're going to do base times height, or 10 root 2 times 10 root 2, which is 100 root 4, which is 2, so that'd be 200 centimeters squared. All right, we are set. Thank you so much.